All right, guys, so today we're going to talk more about functions and the certain things that we should pay attention to when we are talking about a function. So one of the main things that we need to pay attention to when it comes to functions is domain and range, which really domain and range are just fancy words for the x values, like all the x values that this function can possibly have. And then range is just a fancy word for all of the y values that this graph can possibly have. So Discrete is a helpful acronym is the right word, I think, to help us remember that domain, input, and x values all mean the same thing. Sometimes another way to think of input is independent, because the independent variable is my input or domain or x values. And again, these are all the possible ones. So all x values possible for the function. And ROI stands for range, output, y values, because again, they all mean the same thing. When I'm talking about the y values, I'm talking about the range. When I'm talking about the outputs, I'm talking about the range. Okay, so all these words mean the same thing. And now the other one that kind of goes along with your output is the dependent variable. So like whatever the dependent variable is dependent on the independent variable. So that's kind of why when I talk about in story problems, what had to happen first. So whatever had to happen first is the independent thing, and generally it's time, because as more time goes on, that will change or make it dependent on what the y value is going to be, sort of. So this is generally a time variable if we're thinking straight problems. And again, ROI, range, output, y values, these are all y values that are possible. Okay. Now you might think that's pretty simple, and sometimes it is very simple, and sometimes it is less so. It is all dependent on what type of thing we're looking at, what type of representation of a function we're looking at. So I think we're going to start with this little book here. We got 3 books to take a look at. All of these, which these two look very similar. There's a slight difference. We're going to look at those two second. We're going to look at this one first. So domain and range, again, we kind of already said it. I'm going to skip that. If we look at this first example, something that is discrete is pretty easy to find the range of, because what discrete means is individual points. So kind of like what we were dealing with yesterday, when I have a scatter plot, I have individual points. And so in that case, it's actually pretty easy to find our domain and range, because there's only a set amount. There's not a lot. So I can just list what they are. So for instance, if I'm looking at this function right here, which is actually not a function because the 2's are repeating themselves. So this is actually just a relation. I can list the domain, which again, domain is just a fancy word for x values. But I like going through and just straight up listing them. And again, I kind of like to do it in order. So 0 is the smallest. And I kind of cross them out as I go to make sure I don't miss any. I don't see any 1s, but I do see a lot of 2's. And then 3. Okay, so those are all of our domain values. Those are the only x values that exist in this relation. Range is the fancy word for y. So now I kind of look through and I find my smallest y value, which is -1. And I kind of cross those out as I go just to make sure I get them all. And then I have a 1. And then I have a 2 and a 3. And then we got all the y values. So again, there's only so many. These are the only points that exist in this relation. And so I can really just list out all of the x values and all the y values. Same thing when I have scatter plots like this, which both these don't seem to be following a trend, but I can just list the domain. So I start with this first point here, and we're looking at its x value, which is -3. Then this one is at -2. This is at -1. Nothing at 0, nothing at 1, but then there's something at 2. Then I want to list all the y values or all the range values. So now I start at the bottom because like I want to go in order from smallest to biggest. So the smallest y value is at -3. Nothing at -2 or -1, but then there is something at 0. Nothing at 1, but then we got a range at 2. And again, that's all of the points that there are, so it's really easy to just list them. And so if we try another here, if we go domain first, we're going to go across the x to sort of see if there's a point there. And there's one at -3, also -1, 0, and 2. As far as range values, the y values go, the smallest is -3. Then I have a 0, and then I have a 2. Oh, look at that. They have the same range. That's cute. Coincidence. Actually a coincidence. That's so weird. Okay. On to the next. So discrete is really nice because I can just make a list. I can just look for the x's, write them down, look for the y's, write them down. However, once I start getting a smooth line and not just individual points anymore, we have something that is called a continuous function. So continuous means like a smooth line. And more specifically, that goes on forever. These ones don't really go on forever, but this is a smooth continuous line. There's just too many x values for me to list. Like if I look at this graph here, there is points at -1 and 0, but there's also all of these little points that exist on this curve in between -1 and 0. I can't possibly list all of those. There's an infinite amount. And so when we get to sort of these smooth lines, instead of being able to say just each individual value, I really have to provide a range of values, okay? Because this kind of has a beginning and an end. So if I think about going across the x-axis, sort of the beginning of the graph is here. And as I go through x, sort of the end of the graph is there. And so in terms of x, the smallest x value I have is -1. The largest x value I have is 3. And all of the x values that exist on this cute little oval are in between these. And so when I say an in-between thing, we have an and compound inequality. So that was the one that had like these little less than symbols right here. Because truly what you're saying is that x is bigger than -1, which it is, but staying smaller than 3. So everything in between here. And it is equal because it is a smooth filled in line at those spots. Now in terms of range are my y values. And so we're looking up and down. And again, I want to start at the bottom, like the smallest. And the lowest that this graph ever gets is down here at -2. And then the graph goes until it gets all the way up here. And so you're kind of like boxing it in. The smallest y value that I have is -2. All the way up to 4, that's as high as it goes. And all the y values that I have are in between. So we do an and inequality again, and it is equal to. Okay, so kind of a little weirder. But if we take a look at this next one, if we think about domain, so the x values, we're thinking left to right because that's the way that x goes. And as far left as this graph gets is right here. And it gets as far right as over here because it kind of doesn't go outside of those left or right bounds. And so this is all the way at -2 up to +2. and x is in between. And we have our less thans. So it's like always going to be less than because that's how an and compound inequality works. So less than always. You're going to have your variable here and then a small number here and a big number there. Now, when I look at this one though, at the -2, there's like this closed circle, which that is important. It's telling me it is equal at that spot. And the reason I point that out is because over here at +2, it's an open circle, which means that it's not really equal at the 2, and so I shouldn't put a line under it. Now, when I think about range goes up and down. So as far down as this graph gets is all the way down here. That's as low as it goes. There's no more graph underneath. And it gets as high as this up here. And so the lowest it got was -3. We're talking y values. The highest that it got was, I think that's actually a 5. 1, 2, 3, 4, 5. I may have said 4, but I think that's a 5. Always less thans. And then at both of these like low and high spots, it is a solid filled in line. So that's equal to. You might be asking yourself, like, Missouri, if I'm looking at a line, like, how will I know that it's not equal to? You would have something sort of like a dashed line, and that would not be equal to. Then I wouldn't put the little bar underneath. And that's a super good question, by the way, that you were thinking in your head just now. Okay, last one. So if we take a look at domain, we're going x, so left to right. This graph goes as far left as this point and as far right as that point. Like there's no more graph anywhere else hiding. And then range is up and down, so it goes as low as this and as high as that. And so now if we think about that left and right value, as far left as -2, and then as far right as 1. At the -2, open circle, so not equal, but at the 1, it is equal. Range is going up and down, so we got as far down as -5, and then as high as 1. At the -5, that's that open circle again, so not equal, but up here it was the closed circle, so equal. Okay, so the last one that we're going to do in this booklet here is similar to this. However, because we have the solid filled in lines, however, at the ends, I don't have like these end points. Here I have like endings, like it begins and ends. These ones have arrows, so they kind of go on forever. And so the way I think about these ones is I actually think a little bit of a different way. I know we were going left to right and like sort of boxing these in. I can't really box stuff in anymore because it doesn't have an ending. And so what I do instead is I think about which way the arrows are pointing. So I really go to my arrows. Sorry, I was looking for a pen. And I think about which way it was pointing. So thinking about domain, if I go to this arrow here, this arrow is pointing to the left. It's also kind of pointing up. When I go to this arrow is also pointing up, and it's also going to the right. Okay, so again, domain goes left and right, and this graph goes left and right, and arrows mean forever. So if I'm going left forever and right forever, eventually I'm going to cover all of the x values. And so my domain is all real numbers. Now, if you want to be real cute, you can use this double R, like a double bar R, to represent all real numbers if you wanted to. The range, however, the range is only going up. So like going up forever, like it will get to a lot of them, but since it's only going up and not going down, it must have had like a bottom. And I can see the bottom is actually right here. And so the range kind of started at -3, And then all the y values got bigger than that. And because it's a solid dot, it's greater than. I hate how I wrote this. I'm going to swap it around because I really want to think y is greater than or equal to -3 because up in my brain is greater. So, oh my gosh, ignore that. I hate it. I'll say it better next time. So all the y values got bigger than -3. It kind of started at -3 and went up from there. Okay, looking at our next one, we have arrows. So I'm going to go to the arrow and think about which way it's pointing. And so this arrow here is pointing down and left. This arrow over here is also pointing down, but right. So we're going left and right. Left and right forever means that I'm going to have all real numbers. So you can use that double bar R to do that if you like. The range, however, is only down. We're not going up and down. We're just going down. So that kind of means there must have been a top, like a point it started at and then went down from. And so I can kind of see that the top of this graph is right here. And so if I say this a better way now, all the y values are getting smaller and smaller and smaller, or less than this 1, because it got as high up as 1 and went down from there. And again, it is equal to because that is a solid filled in line. Okay, last but not least on this one here, if I think about the way that this arrow is pointing, it is pointing left and down. This arrow over here is pointing right and up. So if I think about the domain, we're thinking about left and right. This graph goes left and right, so that's all. Because if I go left forever, right forever, I'm going to cover all of them. If I think about range, range is up and down. This graph goes down and up, so down forever, up forever. Eventually, I'm going to cover them all, so all real numbers. Okay, so in the other 2 little booklets, we just have a whole bunch more practice problems because this stuff can be kind of tricky. So we will start first with the continuous functions. So continuous are the ones that are like the solid filled in lines. So these are going to be the ones that are a little bit trickier, I think. If I look at domain, oh, dang it, I just put my highlighters away and I kind of want those. Domain is left and right, and this graph starts all the way left over here and keeps going until it gets all the way over here. And so the range is like up and down, and this graph is as far down as this and as high up as that. So when I think about the domain, it started at -2. And all the x values are in between that and 4. And because they are solid filled in dots, we are less than or equal to here. As far as range, the lowest that this graph got was -3. All y values in between got as high as 4. Again, both solid filled in dots, so both less than or equal to's. Okay, if we think about this next one, left to right, this graph is as far left as -1, like it doesn't exist over here, and as far right as 7. So we're going -1 to 7, solid filled in dots, so equal to's. Then we're thinking range, which is up and down, and so this is as far down as this, like there's no graph below it. And it got as high up as that because there's no graph above it. And so this is as low as -3, filled in dots, so equal to, all the way up to 6. Okay, I'm going to stop with the highlighters just to be a little quicker. So domain is left to right. We got as far left as -2, and then as far right as 4. This is a solid filled in dot, so equal to. This is not, so not equal to. Range is up and down, and it got as low as -3 and high as 3. This is a solid filled in dot. That is not. Ooh, this one is interesting. So this one kind of has a beginning, but then an arrow. So this arrow here is pointing to the right and very slightly up. So when I think about domain, domain is left and right, but this is only going to the right. So that means that x is getting bigger than something. And so if I look back at kind of where the x values started, they sort of started here at 0, and they continued bigger and bigger than that. And it's equal to, because it's a solid filled in dot. This is also going up, so y is going to be greater than however low it got. So this sort of started this low, which is 0, and again, solid filled in dot. I love it. Domain and range is so fun. Oh, this is similar to one we did before. So we have arrows. This arrow is pointing left and up. This arrow is pointing right and up. So because we're left and right, domain is all. And because we're up and up, that means that range is greater than something. And this got as low as -3. Like it's not to -4, so -3. And it is equal there. Okay, last one I got over here. This got as low as -5 on the x and as high as 6, or I guess as far left and right. Equal at the -5, but not equal at the 6. Then this graph got as low as -4 and as high as 2. And both of these spots are filled in lines, so they're both equal to. It doesn't really have to do with the dots because those were left and right. Up and down are kind of these curves. Okay, so I think that that's the trickier one, but I will still do the discrete. So if you're looking at discrete, these are going to be individual points. So these should be much easier to just list. So like here, the domain is -5, -2, 0, 3, 6. Range is -23, -14, -8, 1, and 10. Like those are the only values. That's it. So you just list them. Here, your domain is -4, -1, 0, 2, 7. Range is -5, 0, 1, 2, 4. Because again, if you remember, inputs, outputs. There's a thing here. Don't worry about it yet. Next, if I'm looking at this set of points here, I got a domain of -2, 0, 1, 6. Range, I have 0, 1, 3, and 4, just to go in order. We got a scatter plot over here. My domain values, there is a point at -4, also -1, 2, and 3. Now range is up and down, and so the lowest is -2, then 1, then 4, then 5. And last but not least, oh my goodness, these are easy again. -5, -3, 0, and 2. No need to list them twice. And then over here we got -5, -3, 0, and 6. And then for my points again, we got a point here at -3, also at -2, nothing at 1, but I do have one at 0. And then over here at 3. Range is up and down, so the lowest is -4, then a 0, then a 2, then a 4. All right, I'll see you on the next one, guys.